So when you look at these stages of decomposition, fresh, bloat, active decay, advanced decay, skeletonization, all of those other processes that we talked about are taking place. So here, this is bloat. Well, what causes bloat? Putrefaction. You can see the discoloration that's from autolysis here. And so, this is a stage of decomposition. So fresh comes before this. Fresh just means, it looks basically alive, but it's not. Bloat is bloated. Active decay is when you can see insects, you can see microorganisms, you might see, mice and other scavengers taking part in this. Another thing to note with active decay and advanced decay is the death of the vegetation surrounding these remains. So as decomposition is happening, all of the fatty acids and other elements of the body are leaching out into the surrounding soil, and maybe in the long term having remains decomposing underneath a tree or underneath grass or whatever might be, ooh, look at all these nutrients. But during decomposition, it's actually deadly to those plants, so it will kill them. And so you see the surrounding vegetation is dying. And that's a standard process. So when you're looking at this, you're not just looking at the remains, you need to be looking at the surrounding environment as well. This is somewhere between advanced decay and skeletonization. You still see this death of the surrounding vegetation. It's mostly bone. There might be some cartilage, maybe. It looks like, there's some sort of soft tissue elements remaining, but for the most part, this is just a skeleton. So we actually will talk about taphonomy twice during the semester. We talk about it now at the start of the death of this individual, and we'll talk about it again at the end in a little bit more detail when, I don't know, this class sort of works in a circle. So we start and end with taphonomy, really. So erosion, right? Whether it's wind or rain or moving soil or whatever, right? Erosion does work on remains. Compression means, they're being compressed by weight. Burial, especially if it's not in a standard casket, causes compression, which can cause bones to break. It can cause them to become sort of just weirdly shaped if it's a really gradual compression. Scavenging. So scavengers can take bits of bone away. These little vertical striae, scratches on here, these are rodent gnawing. If you see paired punctures, well, that's dogs, right? They've got these big canine teeth and they can puncture these bones with them. So we see a lot of things from scavenging. Staining, I mentioned once already. These remains are very, very stained. So they likely took up elements from the soil, which caused them to become this dark brown color. This is flaking, right? On top of the scavenging, you see a lot of flaking. Well, bones dehydrate after death. There's lots of oil in them naturally, and that oil starts to leach away. And so they're dehydrating, and so by removing the water and oil from the bones, they kind of start to shrink, or they try to. And what that causes is flaking on the outer surface, because the outer surface is that compact bone. So the spongy bone inside, there's more open space. It can shrink a little bit. But the outer layer can't. And so it causes flaking when it attempts to. Sunlight and fire cause that bone dehydration on a much, much grander scale. And so the flaking will become more rapid. The dehydration is much more rapid. So these pictures are showing you, these big longitudinal cracks are the result of relatively rapid dehydration of the bones. These flaking along the outside compact bone, well, that's because of the shrinkage and dehydration. Okay, so these are just going through some of these. And then these final two slides are some of the tables that they're not the final two slides, but these two slides are the tables that I was mentioning that you're going to want to use along with the ones in your book, though these are from the book, but there are more in the book. Look at them, use them to assess the PMI for your case, which again is not going to be like, oh, 2 days. None of you are going to have a 2 days PMI for your case, okay? I don't think. So realize that decomp rate can vary. So it's another reason you want to have a fairly broad window for PMI, especially with skeletonized remains, because there's variation if the individual is buried or not, if they're in the sun or in the shade. You'll notice as you go through these other slides that there's variation there. So pay attention to that, consider it. Let me know if you have questions about it, and let's start looking at this other lecture that I'll. So this is lecture 6, which is that initial treatment and examination. So the last lecture looked at things you would potentially be looking at while you're still at the crime scene. Here you're taking the remains back to the lab. Okay, so this whole process, if the remains are in really good shape, and everything's clean and neat and whatever, could take a few hours, maybe a day. If it's a mess, everything's broken, it's dirty, it's got to be cleaned, it's got like step by step by step, this could take weeks. So this is a highly variable process. The first thing that you need to know is what is a forensic lab. And you may have seen actual labs, you've certainly seen them on TV, almost certainly, I guess I should say. But a forensic anthropology lab is a little bit different. So in terms of high-tech equipment, yes, we have some high-tech equipment. But what's really necessary, you don't have these big DNA sequencers, you don't have, mass specs, you don't have a lot of this big equipment that you would see in a bio or a chem laboratory. Potentially we're working at the medical examiner's office and all of this is in one location. But the things that we need as forensic anthropologists tend to be relatively low key. We need a fume hood because we're going to be using some chemicals. We need some measuring tools like calipers and osteometric boards, which are just big boards with rulers on them and a sliding flat piece that help us measure how long the femur is. We need drying racks, some containers for processing the remains if there is soft tissue on them. We may have a maceration vat, which potentially could be high-tech, but in my experience I've done it a lot less high-tech than that, so that can be variable. So depending on your area of expertise, a forensic lab could look very different. This is me. I am working in a forensic lab there, but I'm working with bone, so it is anthropology research that I was doing, but I was isolating DNA from bone. And so when you're working with DNA, you are more concerned with contamination. And so I was in the whole marshmallow suit. And no, that is not a COVID mask. This was long, long before COVID. So this is just keeping spittle and whatever else off of everything that I'm working with. One of the big things for any forensic laboratory is the lab has to be secured. So nowadays that usually means swipe access and that there's a recording of everyone coming into and out of the lab at every moment of every day. And this is good because think again about taking this all to court. You have to be able to prove, nobody came into this room and messed with any of the evidence. We have this log of everybody that comes in and out. Nobody was in here when they didn't need to be, when they weren't working. And so all of that has to be provable. You have to avoid contamination. If I'm working on this case, I'm not walking around and working on another case carrying this femur around. Oh, I'm going to sit it down on this other table where my lab mate's working on another case and I'm going to take a look at what they're doing. No, you don't do that, right? If you're working on this case, you are working on this case. You don't want to commingle remains, meaning put different cases or people together. You don't want to contaminate other evidence. So you are, like this person is the worst person on here. When photographers come into labs, they tend to not care a whole lot about what you normally do in the lab. They tell you what they want to see in their picture. And so in real life, in a forensic laboratory, hairnets necessary. And so, just be aware of that. So you're avoiding contamination with all of this PPE that you're wearing. And the PPE mainly protects the case, but it's personal protective equipment. It does protect you as well. It's possible when you're working with human remains that they could have diseases. And so making sure that you're vaccinated and that you are observing all of these safety precautions is actually really critical. So now we have the remains, we're in the lab, we're secured, all of that. The first step is initial examination. This is before cleaning, it's before everything else that we're going to do, because if we are about to soak these remains to clean them, we may well wash off some evidence, and we don't want to do that. So initial examination means we are looking for blood stains or other things that it might wash off if we start to clean the remains. So we want to record those. So this is a blood stain on the zygomatic, and this would be evidence of bruising around time of death. And if you were to put this, in a washing vat or whatever, and scrub a little bit, that would come right off. So you would have lost that evidence. If there is a lot of soft tissue, then that has to be removed. I always have this picture because I used to work with a dermestid colony at UB, but dermestids, listen to my words, are not the best method for bulk soft tissue removal because of how long they take and how very high maintenance the little colony of beetles is. Dermestids are flesh-eating beetles. They only eat dead things. So don't worry, like the mummy, and they come and start to eat you. They don't do that. So if you're not feeding them remains, then you have to go to the butcher and you have to get them meat, and they have to be kept at a certain level of light and a certain temperature, and they're very, very picky little guys. So they're actually not used in forensics very often. Usually, we macerate. And this means removing that soft tissue by soaking. And so you never soak them in boiling water. There always has to be a little bit of enzyme in there to break down fats and other connective tissues, but essentially water with enzyme and probably a little bit of bleach at the end is what's going to get all that soft tissue and oils, etc., out of the remains. So again, you want to have looked at them first because you want to see what's the level of oil left in the remains. Because by the time we're done with maceration, there won't be any. And so that might help with the PMI. You want to make sure you've done the PMI before you're macerating. We reconstruct. This means if there are broken bones, we glue them back together. We don't tape them. We don't super glue them. We glue them with Elmer's glue. So this is my hand in a nice little purple nitrile glove. And I am sitting here for an inordinate amount of time holding this person's face together while the Elmer's glue dries. It is not my favorite thing. I don't think it's anybody's favorite thing. It's difficult, but it's important that it's done in the right way because, so for instance, when I was working, these are from the Erie County Poorhouse Cemetery. When I was working there, I then needed to do some dental analysis, and my roommate at the time was in charge of dental analysis, and he had glued in all of the teeth that we had found in all of the graves, like put them back in the right places and glued them in. But I needed the teeth without the skull. If he had super glued them, I would have had to break the mandible or the maxilla in order to get the teeth out. But instead, he had followed directions and he had just glued them with Elmer's glue, so all I had to do was dampen a little Q-tip, get some water in there, and I could pop the tooth right back out. And so it's really, really critical that this be a reversible process, though it's an important process to go through because when the teeth are all in situ, then you can see wear patterns. When the skull is put back together, you can see break patterns. So it is important to be able to see these things, but it's also important that they be reversible. I'm going to start this in the third and final installment of this intro.